So right now, basically what we have is just a simple remote control quadcopter, just controlled with our transmitter here. Communicates with the receiver, which then inputs yaw, pitch, roll, elevator, throttle signals to our Panda board, or our hoverfly board, which is like control board, just commands the DC motors to do what they do. So basically, our Panda board is going to take the place of our receiver here. All the stuff over that Chris is working on with the communication, which is basically you're going to have to send PWM signals into this, and then yeah, it's pretty simple. Well, not really, but yeah, we've had a lot of accidents, broken a few times, as you can see. It's kind of got its battle scars, but it's actually pretty durable when it comes down to it.
We're using the SIFT algorithm to detect an Arabic sign. So this will be where our flash drive will be. This is where our flash drive is going to be located at. So this is the code right here. We're running it off of our Panda board microprocessor, and so we've built an image processing library known as OpenCV, and we're using a lot of different things with OpenCV. So after compilation, we run the SIFT algorithm. And right now, the video is not visible because we're running Ubuntu Server Edition. So what's displayed is the frames per second. Right now, we got the frames per second to be around 5, between 4 to 6, let's say. And so right now, when we put the sign in front of the camera, you can see on the screen it's displaying that it's receiving a good match. And so if we rotate the sign, it's still going to detect the it's still going to detect the Arabic symbols, and so that's pretty good. So that we don't have to worry about scale and orientation. So the max distance that we got it to reach right now is around 3 to 4 feet, which is pretty good. Other than that, we're getting very good matches.
This is a common base amplifier, the BJT, so it's a common base. As it's the realization of the circuit schematic over there. It's just a common base amplifier. It's biased at about 2 volts, and the input voltage is a signal that looks vaguely like this, from 0 to 1.8 volts, and it outputs here from 0 to 5 volts. Its job is to convert this 1.8 volt signal to a 5 volt signal, and as we see here, the peak-to-peak value is just over 5 volts.
So now we are going to stream data off this laser rangefinder and show the resulting data in application. And then we get the displayed data right there. It's pretty cool. So that's the room that we're looking at. Corner right there. Pretty cool.